Scientific consensus is the collective judgment, position, and opinion of the community of scientists in a particular field of study. Consensus generally implies agreement of the supermajority, though not necessarily unanimity. Consensus is achieved through scholarly communication at conferences, the publication process, replication of reproducible results by others, scholarly debate, and peer review. A conference meant to create a consensus is termed as a consensus conference. Such measures lead to a situation in which those within the discipline can often recognize such a consensus where it exists. However, communicating to outsiders that consensus has been reached can be difficult, because the normal debates through which science progresses may appear to outsiders as contestation. On occasion, scientific institutes issue position statements intended to communicate a summary of the science from the inside to the outside of the scientific community. In cases where there is little controversy regarding the subject under study, establishing the consensus can be quite straightforward. Popular or political debate on subjects that are controversial within the public sphere but not necessarily controversial within the scientific community may invoke scientific consensus. Note such topics as evolution, climate change, the safety of genetically modified organisms, or the lack of a link between MMR vaccinations and autism. There are many philosophical and historical theories as to how scientific consensus changes over time, because the history of scientific change is extremely complicated, and because there is a tendency to project winners and losers onto the past in relation to our current scientific consensus. It is very difficult to come up with accurate and rigorous models for scientific change. This is made exceedingly difficult also in part because each of the various branches of science functions in somewhat different ways with different forms of evidence and experimental approaches. Most models of scientific change rely on new data produced by scientific experiment. Karl Popper proposed that since no amount of experiments could ever prove a scientific theory, but a single experiment could disprove one, science should be based on falsification. Whilst this forms a logical theory for science, it is in a sense timeless, and does not necessarily reflect a view on how science should progress over time. Among the most influential challengers of this approach was Thomas Kuhn, who argued instead that experimental data always provide some data which cannot fit completely into a theory, and that falsification alone did not result in scientific change or an undermining of scientific consensus. He proposed that scientific consensus worked in the form of paradigms, which were interconnected theories and underlying assumptions about the nature of the theory itself, which connected various researchers in a given field. Kuhn argued that only after the accumulation of many significant anomalies would scientific consensus enter a period of crisis. At this point, new theories would be sought out, and eventually one paradigm would triumph over the old one, a series of paradigm shifts rather than a linear progression towards truth. Kuhn's model also emphasized more clearly the social and personal aspects of theory change, demonstrating through historical examples that scientific consensus was never truly a matter of pure logic or pure facts. However, these periods of normal and crisis science are not mutually exclusive. Research shows that these are different modes of practice, more than different historical periods. Perception of whether a scientific consensus exists on a given issue, and how strong that conception is, has been described as a gateway belief, upon which other beliefs and then action are based. In public policy debates, the assertion that there exists a consensus of scientists in a particular field is often used as an argument for the validity of a theory and as support for a course of action by those who stand to gain from a policy based on that consensus. Similarly, arguments for a lack of scientific consensus are often encouraged by sides who stand to gain from a more ambiguous policy. For example, the scientific consensus on the causes of global warming is that global surface temperatures have increased in recent decades and that the trend is caused primarily by human-induced emissions of greenhouse gases. The historian of science Naomi Oreskes published an article in Science reporting that a survey of The abstracts of 928 science articles published between 1993 and 2003 showed none which disagreed explicitly with the notion of anthropogenic global warming. In an editorial published in The Washington Post, Oreskes stated that those who opposed these scientific findings are amplifying the normal range of scientific uncertainty about any facts into an appearance that there is a great science.